All right, so in my sandbox, I'm going to create a new file, and it's going to be called, I'm just going to call it room.java. And I've made my first mistake. This should have a capital R at the beginning. Oh, no, that was what happened. There we go. Rename. Should be room.java. There we go, with a capital R, because we are building a class. So you do not need a main method within our room class. Our main method is going to be in our my program. Now, what kinds of things do we need to know about a room? Let's assume we're working with a rectangular prism shaped room. It's not a weird shape. So it'll have a length, width, and a height. So what type of data should each of those be? They should be integers. You're correct. So we're going to have a private int length, private int width, and a private int height. So we've got our 3 dimensions, and then let's say we have the name of the room. That's going to be a private string name. So what kind of a room is it? Is it an office? Is it a bedroom? Is it a living room? That seems like a good amount of data for a single room. We could add more things, but for now, for simplicity's sake, let's just work with this. So the first thing we need in a class is the constructor for that class, so that we can create objects of this class type. So we're going to make a public, and the name of a constructor is going to match the name of the class. So we're going to make a room. Anytime we make a constructor, we need a parameter list. Let's make multiple constructors though. So let's start with a default constructor that takes no parameters. Our room, we're going to have, let's say our default values are 10, 10, and 10. So length equals 10, width equals 10, and height equals 10. And our name is going to be basic. This is a basic room. So if I create a room with no parameters, I am going to make a basic 10 by 10 by 10 room. If I make a different constructor with the same name, because that's how constructors work, they're going to have the same exact name. This one, I'm going to accept 3 or 4 parameters, so I can actually fill in my my instance variables. So I'm going to make a variable to represent the length. I'm going to name it L. I'm going to make one for the width, one for the height, and one for the name. So in this constructor, I'm going to fill in each of my instance variables with those parameters values. So length equals L, width equals W, height equals H, and name equals N. So we're initializing all of our instance variables with these parameters we've been passed. So in our myprogram.java, here is where we can actually make some rooms. So I can make a room basic room equals new room, and room office equals new room. How big is an office going to be? Let's say 15 by 10 by 20 feet tall, and it is an office. What will happen if I try to print each of these? System dot out dot print line basic room, and system dot out dot print line office. All right, let's see if this code even actually runs. All right, the code runs. We have created 2 room objects, and then those are our, I think, something akin to a memory address. Now, this is not a super useful output. So another method that we might want to create is a toString method, so that when I actually try to print out my object, I see my actual information about that object. So we're going to make a public method. It's going to be called toString. Now, when I create a method, I also need to define what its return type is going to be. So if I'm making a method that's going to turn something into a string, I'm probably going to want to return a string. So our toString method doesn't need to accept any parameters. So it's automatically going to be called when we try to print our object. So we don't need any parameters for this. And we want to create some string that will represent this room. So we'll probably want to print out the values of our length, width, and height, and the name of this room. So let's say our string, return string equals a, maybe an, plus name room with, and then return string plus equals. And let's add a new line, a width of plus width a height of height and a length of length, period. And we will return string. So that should, instead of printing out this stuff that's kind of not useful to us, when I run this, when I'm printing out my, oh, I forgot a semicolon. Let's try that again. All right, so we have a basic room with a width of 10, a height of 10, and a length of 10. And we have an office room with a width of 10, a height of 20, and a length of 15. And that seems to match up with the stuff we put in our constructor calls here. So what is another thing we might want to know about a room? Let's say what its volume is. How much space is there within this room? So our volume is going to be some kind of a calculation. We'll do that within a method. So let's make another public method. What type do we think the volume is going to be of a room?
Double.
A double, or since we're working with ints for our three size things, I think we can probably just return another int, right? So we'll return an int, public int get volume. We don't need any parameters for this. And we're going to return the volume of this room, which is going to be our length times our width times our height. So we can print our rooms, and then we can say print line. That room has a volume of basic room dot get area get volume. I'm going to call our get volume using the basic room object, because this method is going to reference the instance variables of whatever object you call it on. So we want to grab from our basic room, and we can copy this. And instead of calling it on basic room, let's call it on office and see what our two different volumes are. So our basic room has a width of 10, a height of 10, and a length of 10. That room has a volume of 1,000. Our office has a width of 10, a height of 20, and a length of 15. That room has a volume of 3,000. So that is how we can build all those pieces of a class. Let's look at our study guide and see if there's anything else we might want to build here. Loading strings. I think we can cover strings individually as we look at them. Is there any other functionality that you guys think would be useful to add to this room.java? All right, then that'll wrap up this little segment of our review, how to build a class using all those different pieces. Just a brief overview of what we have just talked about. We've got our instance variables up here at the top. We have our constructors here. We have the default constructor with no parameters, and we also have a constructor that has parameters in it. Since we have two different constructors with the same name but different parameter lists, they are overloading one another. So when I call one or the other from my place that I'm actually instantiating my objects, instantiating my class, Java is automatically going to call the correct constructor because it can see what the parameter lists are. We have defined a couple of methods. We've defined the getVolume method, which will return an integer with however large the volume of our room is. And we have a toString method that is going to take all of the instance variables within our class and print it out in a nice way. And over here, we are creating our objects, printing our objects, and calling the getVolume method on them. So just some terminology from our study guide. Classes are the blueprints we use to build objects. So we wrote our class, and then we can create objects of that class type. And yeah, objects are variables with a class as their data type. When I create an object, I call that class's constructor, and we are going to be initializing all of our instance variables within our constructors. Methods are what we use to use a block of code over and over again, which lets us save space in our programs, which is always great. The signature for a method, we've got our access specifier, we've got our return type, we've got the name of the method, and then any parameters we are going to pass to said method. Usually when we have a method, we need to call it so that actually we're making use of its code. And when we are calling a method that's built into a class, we need to reference that class somehow in order to have access to said method. We can either use, if we have a static method, we can use just the name of the class, or we can use an object to reference to get that method. Parameters, that is the information that we are sending into our methods. The difference between formal and actual parameters. The formal parameters are the ones that we name when we are creating the method or constructor, and the actual parameters are the ones that we are using when we are calling the method or constructor. Yeah, we can overload by having a method or constructor with the same name, but a different set of formal parameters. And then we talked about strings. Since string is a class, it has a large number of methods associated with it that we can use anytime we have a string object. And we talked more about this when we did our iteration stuff, but we can use replace, we can use length, we can use substring, we can use index of, equals, and compare to with strings to operate on them. Replace will replace any instance of the first thing with the second thing and return the result. Length is going to just tell you how many characters are within the string. We've worked quite extensively with substring in our iteration unit, so I feel like we're pretty familiar with it. Same with index of. And then equals and compare to will tell us, well, first equals will tell us whether the string we're calling it on and other string are the same as each other. Otherwise, we will get false. And compare to is going to subtract the ASCII value of your other string from your original string. So if we look at an ASCII table, let me open up my ASCII table. Where's my bookmarks bar? I don't have it. ASCII table. So we look at this ASCII table. Let's say I want the word hello dot compare to yo. We're going to find the first place where they differ. That's H and Y. It's just the first character. That one's pretty easy. We're going to find the value of H, which in decimal is 104. And we're going to subtract the ASCII value of Y, which is 121. Now, the actual result here doesn't make a huge amount of difference. All we really care about is whether it's greater than 0 or less than 0. if the number is less than 0, then our string 1 comes before string 2. If it's greater than 0, string 1 comes after string 2 because it's got a larger ASCII value. And if they're equal, then you're looking at the same word when you are using compare to. All right, any questions on any of the stuff from this unit that you'd like me to cover a little bit better? Good? Cool, okay.